the matrix. Today we're going to be going through how to find first the determinant of a 3x3 and a 2x2 matrix, and then we're going to get into how to use that determinant to find the inverse of a 2x2 matrix. So we're going to start with the determinant. So let's say we have a matrix here. We're going to call it matrix A. And we're going to find the determinant of this matrix. Okay, the determinant of a matrix it's essentially a number that we're going to use the matrix to calculate. And the number has some important, or allows you to find some important properties or characteristics of a matrix. And so the way we calculate the determinant, first, let's just start with a little bit of notation here. Instead of having the brackets on the outside, the determinant has these just lines like this. So these lines indicate that we're calculating the determinant, and the way we kind of write it is like this, det A. The way we calculate it, though, first A, B, C, and D are going to be numbers in our examples. The determinant of A is equal to this. But the way we calculate it is we take the product of these two numbers, so A times D, and we subtract the product of these two numbers, C times B. Okay, and that's it for a 2x2 matrix. So let's say we have a 3x3 matrix. The way we find the determinant for a 3x3 is a little bit trickier. So we're going to start with A here, so A, and then we're going to multiply A by this 2x2 matrix down in the bottom right. The determinant of this matrix, so E, F, H, I. Next, we're going to take B, and we're going to subtract B with this and this. We're going to treat these two columns as a 2x2 matrix. So this becomes B times the determinant of D, F, G, and I. Okay? And then lastly, C is going to be multiplied by the determinant of this 2x2 matrix. So we get plus. So notice the sign is changing from minus to plus. D, E, G, H. Okay, and then to find the determinant, we're going to have to find the determinant of each of these individually. Okay, so A times, well, similar to what we did before with a 2x2, E times I minus H times F, H times F, minus B times G times F minus, oops, I have that backwards, sorry, D times I, so D times I minus G times F. So G times F plus C D times H minus G times E. So let's actually just leave it like that. I think it's a good enough spot that you can kind of get an idea of how this works, and use this as a reference when we go through an example. So this is going to be a number, and this is the determinant of a 3 by 3 matrix. So what does the determinant mean, and where can we apply this to kind of answer some applicable questions associated with matrices? Well, the main thing we're going to talk about in this unit is how we can use the determinant to find the inverse. Today we're just going to talk about the inverse of a 2 by 2. Then we'll get into more complicated matrices next class. Okay, but we're going to try and keep it simple today. So the inverse of A, I'm going to use the same matrix we used at the top. So A, B, C, and D. If I want to find the inverse of this, the way it works is we take the determinant, we do 1 over the determinant of A, and we multiply this by the following matrix. Okay, we switch the locations of A and D, and then we input negative signs here for C and B. The reason why we do that has something to do with the identity matrix. We won't get too much into that for this video, but this is the process to find the inverse. Okay, and then we're just going to evaluate this. Well, we know the determinant of the original A matrix is A times D minus B times C. I'll switch the order here, but it doesn't matter. C times B. And then we multiply this by D, negative B, negative C, and A. Okay, and that's it for a 2 by 2 matrix. So let me go through an example before we do a little bit of practice. So let's say I have the following 2 by 2 matrix. Okay, so we know how to do basic operations when we multiply and add matrices together. Let's find the inverse of this. Okay, so the inverse of this, the inverse of A represented by this term right here. So A negative 1 is equal to 4, 7, 2, 6, negative 1 here. Okay, so we're going to do 1 over the determinant of A times, well, 6 and 4 are going to flip their locations. And then we're going to input a negative in front of the 2 and the 7. Okay, so let's find the determinant of this. So 1 over. Remember, when we're finding the determinant, we're using the original matrix, not this new one here. Okay, so 1 over 4 times 6 minus 2 times 7 multiplied by this matrix here. Okay, well, let's simplify this fraction on the outside. So we get 24 minus 14 times this matrix. And lastly, this becomes 1 over 10. Okay. We could leave our answer like this, but for today I'm going to push you guys to simplify it as one matrix. So this becomes 6 over 10. This is minus 7 over 10, minus 2 over 10, and then positive 4 over 10. And then lastly, we can simplify this one more step if we wanted to. So we get 3 over 5, negative 7 I'll just leave that as negative 7 over 10. This becomes negative 1/5. And then lastly, 2/5. So this is the answer for our example question here. So this is the inverse. It doesn't really look like it would be the inverse, but this is actually the inverse of this function here, or this matrix. And we're going to talk about how we can use the inverse to answer questions associated with systems of equations next lesson, and the lesson after. Okay, so practice. Let's start. We're going to do 2 problem sets. The first is the finding the determinant, and then the second one will be finding the inverse of a 2x2 matrix. Okay, so determinant. Let's evaluate the determinant of these 3 matrices. Notice the way it's written, because there aren't brackets, there are just lines on the outside, that's indicating that this question wants us to find the determinant. So for a 2x2, we're going to do 0 times 0 minus 3 times negative 2. 0 times 0 minus 3 times negative 2. We'll get 0 minus negative 6, which is positive 6. Okay, that's the answer for this first one. So 2x2 generally isn't too bad. Let's do another one. 2 times negative 4 minus 3 times 0 we get negative 8 minus 0, and so that's just negative 8. And that's the answer for the second one. Okay, what happens when we have a 3x3? Well, what I want to do first is let's just, we're going to kind of do this in 2 steps. So number 1 is we're going to take this 4, and we're going to multiply it by the determinant of this matrix down here in the bottom right. So 4 times 1, negative 3, 4, 4, minus, okay, there's a minus here instead of a plus, minus our middle number. It actually won't matter for this one because the middle number is 0 times the determinant of this 2x2 matrix. So 0 times negative 2, negative 3, negative 1, 4. Okay, and then the last term here is going to be 1 times the determinant of this matrix. So plus 1 times negative 2, 1, negative 1, and 4. Okay, now let's evaluate this. Well, the nice thing about this is notice that this is just going to be multiplied by 0, so that will go away. So we have 4 times 4 minus negative 12 okay, well that term becomes 0, so we can ignore that, plus negative 2 times 4, that's negative 8, minus negative 1 times 1 is negative 1. Okay, and now let's simplify this to get our answer. So this becomes 4 times 16 plus negative 7, so minus 7. So 4 times 16, that's 40 plus 24 is 64, minus 7, and that is equal to 57. And that's our answer for this one. So the determinant, remember, is a number, okay? Each of these values, if we want to calculate the determinant, we're going to calculate the, we're going to calculate a value that will be a number, okay? And let's wrap up this video by going through the inverse of a 2x2 matrix. So problem set 2. We're going to find the inverse of each of these 2x2 matrices. It gets a little complicated with 3x3. We'll get into that a little bit next week. But some of these we get to a point where it gets so tedious that you actually just use computers and program how to evaluate these. But with 2 by 2, it's simple enough that we can do it by hand. Okay, so if I want to find the inverse of this, we're going to take this matrix, find the inverse by doing 1 over the determinant. So let's do that first. So 1 over the determinant, well, that's going to be negative 4 times 0 minus negative 6 times 3 times, we're going to flip the 4 and the 6, or the negative 4 and the 0. So 0, negative 4. And then we're going to change the sign of these ones. So this is going to become plus. And we're going to put a minus here in the 3. So 6 and then minus 3. Okay? So this becomes 1 over 18 of this matrix. And now we're going to multiply the 18 through. So 1 over 18 times 0 is 0, minus 3 over 18, 6 over 18, minus 4 over 18. And let's just simplify this one more step. So we end up with 0, negative 1, 6. It's the same thing as negative 3 over 18. 1/3, negative 2/9. That's going to be the inverse of our function over here, or our matrix rather, over here on the left. Okay, number 2. Once you get the process down, the 2 by 2s hopefully aren't that bad. It's just kind of remembering the steps. So 1 over negative 1 times 2, well, that's 2. 1 times 10 is 10, so minus 10. The negative 2 and the negative 1 will flip their location, and the sign of the negative 10 and the negative 1 will change as well. This is what we get for this one. So we get negative 1 over 8, negative 1/8, negative 2, 1, 10, negative 1. Okay? So, if we multiply this through, we get positive 1/4, negative 1/8. 10 over 8 is 5 over 4. And then lastly, this is negative 1 over 8. Or sorry, positive 1 over 8, because they're both negative. So that's our next inverse. A lot of your answers are going to have fractions here because this determinant is usually well, it's 1 over the determinant, so it's usually a fraction. All right, and let's wrap up the video by going through number 3. So the inverse of this is denoted by the following. We're going to do 1 over 7 minus negative 20. Multiply this by this matrix here, so negative 7, negative 1, and then negative 10, and positive 2. So 1 over 27 times this matrix here. Okay. Now let's multiply the 1 over 27 through, so negative 7 over 27. 2 over 27, negative 10 over 27, and then lastly, negative 1 over 27. Okay, and that is the inverse matrix for number 3. Okay, so when you're finished with this, work through the additional practice to get a little bit more practice about how we find the determinants of a 2 by 2 and 3 by 3 matrix, as well as practice finding the inverse of a 2 by 2 matrix. Like I said before, for 3 by 3 and other more complicated matrices, we're going to talk about those going into next week.